Hey everyone, in this video we'll go over how to evaluate algebraic expressions. If we have the expression such as x plus y squared plus z squared, we know that each letter corresponds to a number. So if we took x to be equal 5 and y to be equal to 8 and then z to be equal to 3, we can rewrite the original expression as 5 plus 8 squared plus 3 squared. If we then evaluate the exponents under the order of operations, we then have 5 plus 64 plus 9, which then adds all up to 78, which is the final result. Let's keep the original condition of x to be 5, y equals 8, and z to be 3, and solve another expression. I'm just going to rewrite these here so that we don't forget about them. And then say we're trying to solve this one. We have x times y squared minus 3z all over 3. Well, once again, we can plug in the numbers into the algebraic expressions. So what we're going to have now is we're going to have 5 times 8 squared minus 3 times 3 all over 3. After this, we want to evaluate the exponent first, which would then give us 64 when we do 5 eighths squared. So that's going to turn into 5 times 64 minus 3 times 3 over 3. Then we evaluate the multiplication statement, 5 times 64, which is 320. 320 minus 3 times 3 over 3. And then finally, we want to evaluate 3 times 3, which we know is 9. So 320 minus 9 divided by 3, which then gives us 311 divided by 3. And then we have our final result right there. Let's do another one. Say that we have x minus z squared all over y divided by x plus 2y minus x all over y squared divided by 2. So first thing we want to do is I'm going to go bring the top here and put it down here. This is our original condition, x to 5, y equals 8, and z to be 3. And we plug this in. So then we have 5 minus 3 squared over 8 divided by 5 plus 2 times 8 minus 5 all over 8 squared divided by 2. So first off, I want to say that the big dividing line, just a reminder, between the x z squared and the y divided by x is called a fraction bar, and it just simply means division. You can think of expressions in a fraction bar each having their own parenthetical statements, so I'm going to write parentheses for each of the 4 expressions in the 2 fraction bars. So we're going to have, so you can think of it as each of these 4 little substatements are in parentheses. Let's see, 2. So the first thing we want to do now is to evaluate the exponents. So I see we have a 3 squared and an 8 squared. So we're going to have 5 minus 9 over 8 divided by 5 plus, I'm going to leave that here for now, 2 times 8 minus 5 over, and then this will give us 64 divided by 2. now we're going to evaluate these four parenthetical statements equally. And so in the top we have negative 4 divided by 8/5. We'll leave that as 8/5 for now. Plus, this is going to be 2 times 8 is 16 minus 5. And then over 64 divided by 2 is 32. And then we want to make sure we evaluate the last one. So we have negative 4 over 8/5 plus 11 divided by 32. And now we have a fraction division problem, negative 4 divided by 8/5. So I'm going to turn this into a multiplication fraction problem by flipping the fraction in the lower part. So instead of negative 4 divided by 8/5, I'm going to say negative 4 times 5/8. And we can make this easier to see by turning negative 4 into a fraction by saying negative 4 over 1 times 5/8. And then negative 4 over 1 times 5/8 is negative 20 over 8. And so now we've rewritten negative 4 divided by 8/5 to be negative 20 over 8. Now we want to convert this fraction in order to have the same denominator for these two fractions. I'm going to multiply the first fraction, this one right here, by 4/4. So negative 20 over 8 times 4/4. This will give us negative 80 over 32. Now we can take this fraction, pull it over here. We can add these together, negative 80 over 32 plus 11. 32 is going to be equal to negative 69 over 32. And this will be the final answer. I hope you learned and are more comfortable solving algebraic expressions after watching this video. Thanks for watching.